When we talk about AI risk, it's so easy to get lost in these big abstract ideas. But how do you actually make it real? I mean, how do you go from just identifying a risk to truly knowing its size, its shape, and its actual impact? Well, today we are diving deep into the engine room of the NIST AI risk management framework to look at the one function that does exactly that: measure.
All right, let's get into it. First, we're going to see where the measure function fits into the whole framework. Then we'll dig into something called TEV. That's the core process that really makes it all tick. We'll also cover a golden rule about who does the measuring, which is super important. Then we get to the fun stuff, the specific metrics you'd actually want on your dashboard. And finally, we'll connect the dots and see how all this data drives real-world decisions.
So, first things first, let's figure out where measure actually lives. Because it's not just some standalone step, it's really the critical hub that connects everything, from identifying a risk all the way to managing it.
The whole NIST AI RMF has four main functions. It all starts with govern, which is about setting the right culture. Then you map the context and start identifying potential risks. And right here at step 3 is measure. And honestly, this is where the framework gets its teeth. It takes all those potential risks you found during the map phase and turns them into hard data, into actual evidence you can work with.
And here's the more formal definition. The words to pay attention to here are quantitative, qualitative, or mixed method tools. This tells you it's not just about finding one magic number. Nope. It's about using a whole entire toolkit to assess and monitor risk throughout the AI lifecycle. It's really all about building a continuous feedback loop that's based on solid evidence. Okay, so we've got the what. We know what measure is. But now let's talk about the how. If measure is the function, what's the actual process that powers it? For that, we need to zoom in on a really crucial acronym, TEV. TEV stands for test, evaluation, verification, and validation. This is the practical, hands-on work of measurement. And I gotta say, the most important word on this slide is continuous. This is not a final exam you take right before you launch. It's a constant series of checks and balances that are happening all the time. Now, this is a really fascinating distinction, especially between the V and V in TEV. Verification asks a pretty straightforward question. Are we building the system right? In other words, does it meet all the technical specs we wrote down? But validation asks a much bigger question. Are we building the right system? Does it actually solve the real-world problem for our users and do it safely and effectively? You absolutely have to have both.
And this timeline just shows you how deeply TEV is woven into every single stage. Way back in the design phase, you're testing your basic assumptions. During development, you're validating the model itself. When you go to deploy, you're testing how it integrates with everything else. And this is so critical, once it's live in operations, you're constantly monitoring it, tracking its performance, and seeing if it needs to be recalibrated. It never stops. Okay, so we know what we're doing and how we're doing it. But there's a vital principle we have to talk about before we even get to the numbers, and that's who is doing the measuring.
And the framework is crystal clear on this point. It says that assessments should involve experts who were not the frontline developers. Now, this could be a separate team inside your company, or it could be completely independent, third-party assessors. And just to be clear, this isn't about adding red tape or bureaucracy. It's all about objectivity. Think about it. Developers are naturally invested in their own creations. We all have our biases. So separating the people who build it from the people who test it is absolutely fundamental to getting an honest, clear-eyed evaluation of the system's true risks and performance. All right, now for the fun part. We've got our process, we've got our objective assessors. So what are they actually measuring? This is where we start building out that AI health and risk dashboard. Seriously, if you were a manager looking at the health of your AI systems, what are those vital signs you need to see at a single glance? What would you put on that dashboard? For pretty much any classification system, the journey begins right here with something called a confusion matrix. This simple little table is the absolute foundation for understanding your model's performance. It breaks down every single prediction into 4 buckets: the times you got it right and the 2 very different ways you can get it wrong. Now, from that matrix, we can start calculating some key metrics. First up, the false positive rate. This tells you how often the system incorrectly flags something. Think of a spam filter that accidentally deletes a really important email. On a risk dashboard, you could track this with a simple red, amber, green gauge to see if it's staying within your acceptable limits.
And then, of course, you've got the false negative rate. That's how often the system misses something it should have caught. Now, if you're building a medical diagnostic tool, this number is way, way more critical than the false positive rate. Your context is everything. It determines which errors you care about most, and your dashboard has to reflect that priority. But performance isn't the only risk we care about, right? What about privacy? Well, our dashboard needs privacy metrics too, and these often come from a set of techniques called privacy-enhancing technologies, or PETs. These give you measurable ways to protect user data. Things like k-anonymity and L-diversity offer specific, trackable safeguards.
The real gold standard in privacy these days is something called differential privacy. It sounds complex, but the core idea is pretty elegant. You add just enough statistical noise to a dataset so that you can still get useful insights from the whole group, but it becomes mathematically impossible to know if any one person's data was even in there. It's a provable mathematical guarantee of privacy.
Okay, so we've gathered all this incredible data: false positive rates, privacy guarantees, performance benchmarks, but data sitting in a report is totally useless. The entire point of all this work is to fuel the final function of the framework: manage.
And this slide just lays out that workflow perfectly. You take the raw quantitative data you got from your measure activities, you convert it into a really easy-to-understand risk score, like that red, amber, green scale we saw. And that, in turn, allows leadership to immediately see where the biggest problems are and prioritize their actions and resources to manage those risks.
So when you boil it all down, what this all means is that the measure function is what transforms AI risk from a subjective guessing game into a data-driven science. It lets you move beyond just vague concerns and actually manage your AI systems based on objective, defensible, and continuous evidence. And that really leaves us with one last question to think about. Because it's not just about having the right tools, it's about embracing the mindset. Is measurement just a one-time thing you do to check a box? Or is it a continuous, objective, and central part of how you actually build and deploy AI? In other words, does your organization have a true AI measurement culture?